All right, everybody. I'm really not trying to cheat the game here, but I'm stuck. I'm at school. I don't have any hats or anything like that, but I do have my blue light glasses. So keep that in mind because I'm going to talk about why these are so important later on. These are becoming a little bit more of a fad right now. Not just a fad, but important because we're looking at computers so often. So I'll talk about that in a little bit. I wanted to start on this slide simply to say, all right, Mr. Woodard, obviously did a fabulous job talking about conscious, preconscious, unconscious, how the preconscious and the unconscious fit under the umbrella of non-conscious state of mind. Conscious, of course, is those things that we're aware of. Preconscious is we can pull up a memory just like that. And the unconscious is processing that's going on a quite deep level. Our book likes to talk about dual processing, how things are happening both at an unconscious and conscious level at the same time. So the question starts to become, where does sleep fit in all of this? So let's talk about the basics of sleep. And Mr. Woodard, I have to thank you because this is like one of my favorite things to talk about. I know that you love talking about it too, and we'll have plenty to add. All right. So sleep. First of all, we need to know the term circadian rhythm. And most people already know this particular term. This is a pattern that our bodies acclimate to, and it repeats about every 24 hours. And it's actually a little bit over 24. It's closer to 24 and a half hours. And why that's important, well, I'll explain a common term and why that's important to this common term. So first of all, going back to our etymology, we love our etymology. Circa is around, diem is day, so around a day. I don't know that you'll ever need to really know this particular term on an AP exam, but suprachiasmatic nucleus is just way cool to say. And if you can throw that out at your parents when they say, hey, what'd you learn in school today? Oh, I just learned that our suprachiasmatic nucleus is where our circadian rhythms originate. You'll sound really smart. So these are going to originate in the hypothalamus in these two little nuclei called the suprachiasmatic nucleus. And then the pineal gland is going to produce melatonin. And again, most people have heard about melatonin. Melatonin is the hormone that fires that helps us to sleep. This is why blue light glasses are so important. When we're looking at a computer screen or the screen of a phone, we're getting blue light. Blue light actually inhibits the release of melatonin. Hence the reason all the sleep scientists all say don't look at computer screens late at night. Don't look at your phone late at night. Why? Because it's inhibiting melatonin being released, and so you naturally are going to stay up later. If you want to see a really cool story about 5 years ago, maybe not that long, look up Oklahoma State Cowboy football team. There's a great little video about them and the sleep scheduling that they did in order to ensure melatonin was fired off on time, they were sleeping correctly, and sure enough, performance on the field went up. And one of the things they did was wear blue light glasses. Now, these are fancy now. These are getting to be more stylish. The originals are these bigger orange glasses. I've got a pair at home. That might be what I wear next time, at least at the beginning of the video. All right. So one of the other things about melatonin that's so interesting is that in younger people, such as your age, you fire off melatonin later in the evening. So you naturally stay up later than adults do. What happens is you get a school schedule or any work schedule that asks you to get up and ready earlier in the morning. It's harder on you than it is for older people. Okay, I get tired around 9 o'clock, 9 to 10 o'clock. I'm getting kind of tired. Why? Because my melatonin's starting to fire off. You're probably wide awake at 9 or 10. Now, some of you have gotten yourselves acclimated to a different sleep schedule, and your circadian rhythm has fit into that schedule. But for the most part, melatonin is getting fired a little bit later in the evening for younger folks than for older folks. It's one of the main arguments for starting school later. You'll hear about school districts starting school later simply because the younger mind isn't ready to learn at 8 in the morning necessarily. I've mentioned circadian rhythms and that 24 and a half cycle being important for jet lag. With jet lag, there's always this controversy. Is jet lag worse going west to east or east to west? Well, they have found that it usually is worse going west to east. Why? Well, when you are landing in New York City and it's 10 o'clock in Spokane and 1 o'clock in New York City and you've lost 3 hours, but the circadian rhythms take 24 and a half hours to fully complete, you've lost that time. So it's going to take you longer to regain that time that you've lost. If you go east to west, you've gained hours, and that's going to help you in regrouping. Like if you go take a trip to New York and then come back to Spokane, you'll be able to regroup faster coming back to and gaining those hours because your circadian rhythms will acclimate sooner. Okay. And Mr. Woodard had a great little note here about the 2017 Nobel Prize going to researchers who discovered or talked about the genetic basis of circadian rhythms. You can look that one up. Okay, so with sleep, there are 4 different stages of sleep. Now, this is going to be important. I can't remember in your book. I didn't look it up before I started recording. A lot of textbooks still say 5 stages of sleep. Okay. There's only 4. Again, about, I want to say 6 or 7 years ago, they actually said that the last couple of stages of sleep are really 1, and I'll show you that on a chart here in a second. So we're going to talk, when we talk sleep, we're going to talk about waves again. Remember the EEG measuring electrical activity in the brain? Well, we're going to look at frequency and amplitude of those signals. And so in general, as sleep gets deeper, the question is, what happens to frequency and amplitude? Well, let's find out on the next slide. Here we have relaxed wakefulness. Those are called alpha waves. They're pretty short, so the amplitude's low, and they're very frequent, high frequency. Then you get into a stage 1 sleep, and you get into theta waves. Now the frequency starts to dissipate a little bit, and the amplitude starts to go up. In stage 2, you can see that you're starting to get a little bit more amplitude, a little bit wider frequency, but then you'll get these things called sleep spindles, and they're super high frequency and medium amplitude. And then you'll get a K complex in stage 2, and you'll see here wide frequency, big amplitude. And that drifts you into stages 3 and 4. Now, stage 4 no longer exists in the literature. They combined 3 and 4. We've got some older slides on this. Just remember, there's only a stage 3. Stage 3 is high amplitude, low frequency. Okay, low frequency. And then you get into REM sleep, and this is where you dream. And you can see here with these waves, all of a sudden, the amplitude gets very short and the frequency goes up. Okay, so when we look at definitions, we have beta waves, which are high frequency and low amplitude. That's when we're awake. That's what you should be all having, hopefully, right now. If you start to kind of drift, you're reading a book and you're starting to kind of drift, and you've got relaxed wakefulness, you'll have high frequency, medium amplitude. Theta waves start to get you into that NREM 1, that stage 1 non-REM sleep, medium frequency, medium amplitude. You'll get into non-REM sleep stage 2, lower frequency, medium amplitude, and then you'll get your sleep spindles, and then those occasional K complexes, which are delta waves. Low frequency, high amplitude, and you're going to see that in NREM 3 and K complexes. Now, we'll come back to all of this. I just want you to be aware of the different terms, and then you have that nice little chart. Now, I wanted to get through this one, though, because this is a key chart. Key graph. All right, this is what happens during a night. You're awake, and then you start to fall asleep. This is a good sleep cycle. As you go, you'll go through stage 1, stage 2, and then down into stage 3. Again, stage 4 doesn't exist, just as this is all stage 3. And then you start to come out of it, and you go up and up and up again. And REM sleep now takes the place of stage 1. There's no more stage 1, you just go into REM sleep. And then you'll do that throughout the night. You'll go back to stage 2, down to stage 3, and then back up into REM sleep. And then you'll notice that stage 3 starts to disappear. Or I should say the real deep sleep starts to disappear in stage 3. And you'll start going into stage 2 and then partially to stage 3, back up to REM. And then by the end of the night, you're just going into stage 2 and REM. This whole thing, that first couple of cycles, one cycle takes about 90 minutes. So if you've ever taken a nap and you've woken up and you feel more groggy than when you went to sleep, it's because you woke yourself up before one of these got done, before one of the cycles was completely through. Or you got through one cycle and we're in the middle of the next. So best nap times are about 20 minutes. You start to go down into here, but you don't go so far down into that deep sleep that when you wake up, you're groggy. So about 20 minutes before you get into the real deep sleep, or about 95 minutes after you've gone through one full cycle. Those are your best nap times. A power nap truly can be refreshing. All right, I've just skimmed the surface of sleeping. I know Mr. Woodard will have much more to say about this, so I'm going to leave off there.